Okay, guys. So let us try this cake problem today in today's video. So cake problem. Ready? So imagine the square is your cake, and let's split it up into 4 even parts, I guess. Nice. And let's say I'm hungry and I just eat this part out. Okay? 4 people are gonna attend the birthday party, and I have, this part's no longer available. So we can raise it. The question is, 4 people are gonna arrive anyway. Doesn't matter that you've eaten the cake. Like 4 other people, not including you. So how are you gonna split this now? Right? How are you gonna split this so that into 4 equal parts so that none of them get dissatisfied and all of them are treated fairly? And it's a really good question, which I would have answered if my stupid computer didn't do that. So now let's go and answer the question. How can we divide this into 4 equal pieces? You might think, okay, let's try doing this, drawing diagonals. Oh well, that doesn't work because let's draw it better. You're like, okay, we got 1 triangle, 2 triangles, 3, but then obviously it looks like these triangles are much smaller than these triangles. So that's not going to work. What else can you do? Then you just start experimenting. 1, 2, 3, 4. No. What else? And you can, I guess, draw smaller lines and divide it up like that. And I think that's exactly the way to go. We can draw smaller lines. So let's draw 2 lines here in the center of this. 1 line here and a line here. And then let's do the same here. So what we've done is we're treating this shape, this rectangle, as 1 piece, and this rectangle as another piece. So we cut this rectangle first into 4 equal bits, and then we cut this rectangle into its respective 4 equal bits. Okay, easy. So now this way, each of them, let's say that's purple. Purple gets one cake. This guy gets the other. Pink gets 1 more. And this guy gets 1. Then similarly, yellow gets 1 equal piece, purple gets 1 equal piece, this guy gets 1, and this guy also gets 1. But then you can stop here. This is efficient. But if you're feeling really stupid, or if you're feeling really ambitious, I don't know what I'm saying, you could go and split this into more equal parts, because the more you split it according to Riemann sums, the more accurate it gets. And that's why when you do this, you can arrive at this approximation, or this solution, where you cut it into such smaller pieces that that even just visually looking at it, it's guaranteed that everyone's going to get the same equal size. However, there are some limitations on using this model. What are those limitations? The limitations are the chef's accuracy, or the guy cutting the cake, right? Is accuracy. Can he evenly cut it? No. There's always human error, right? Slight imperfections that could make the host unhappy. That definitely make me unhappy, seeing my friend get a bigger slice, even if it's slightly by 0.01 centimeters. Like, I'm not gonna feel good about it. So that's a limitation, human error during the slicing. What other limitations do we have? Well, I guess we could share the sharpness of the knife in how accurately it can cut each slice, because you don't want one guy to get more. So that would tie up with human error, but knife. And then we're also going to assume some factors such as, you're using the same knife, and yeah. But then I think that's really the only human limitation, that you have to cut it into all those small pieces accurately. But if you're able to do that, maybe you have a machine at home that can do this. This problem can easily be solved, and you can have an happy party, even though you ate this first half, you sneaky little yeah, I'm not gonna finish it. But yeah, have a good day. That was Sukesh Education.